we all know and we all have been doing this customized Q ablation profile that it can correct the higher order abrasions and induce spherical abrasion. But the actual contribution of the change of spherical abrasion with the sphericity is not known. There's not a proper nomogram for it. So is there a mathematical model that can predict it? So this was a paper published by Professor Gatinel and group, where they tried to remodel the anterior corneal surface using a conic section, and the theoretical values of post-op value of radius of curvature and sphericity were computed. So what, in summary, this paper has shown is the mathematical modeling between the change in sphericity to change in spherical abrasion for various levels of myopic and hyperopic corrections. So this x-axis shows the amount of correction, the sphere or cylinder. So this is the x-axis showing the myopia or hyperopia correction. The y-axis shows the change in sphericity. And these are the desired level of induction of spherical abrasion you want, 0, -2, and -4. For example, if you desire a change of -0.4 microns and the planned treatment is -3, then somewhere the change in sphericity will be -0.55 microns. So roughly, if you want a reduction of spherical abrasion of say about -0.4, then the theoretical change in corneal sphericity will be somewhere close to 0.6. Also, the application is, if the change is on the hyperopia side, you want increased prolitness, this should be taken into consideration, because higher the change of spherical abrasion you desire, the larger is the required change in the sphericity.
Just a question for you. How much Q you need to change a spherical aberration? This is what he talks about, right?
Yes.
So for example, I want a spherical aberration of most of your presbyopia solution is based on how you get a desired spherical aberration, what you mentioned yesterday, of 0.6. You can also be there, Sisimosus. I mean, we're discussing his paper. So if you want a 0.6, how much Q should you change?
Also, the thing is, I think there's a little bit of misconception. What we want to have is a certain amount of sphericity produced. And this you can have very easily calculated, but you don't need to give the pre-op of the patient. At that moment, if you want to induce asphericity, or you want to induce spherical aberration, the pre-op Q value of the patient and the pre-op K readings, they don't play off a role. What you want to create is asphericity of a certain amount, right? And you want to have this reproducibly done every time, right? And you want to have this also refractive neutral, which is not possible with Wernicke polynomials. So what you can do is a very simple way. You just key in 43 K readings, Q value 0 to start with, go to the treatment and change the Q value to a certain amount to get 0.4, 0.5 microns, or whatever you want, and then you go back and you compensate. So in other words, what most people do if they use custom Q to change asphericity, I can't talk about presbyopia because I'm from Alcon right now.
So basically,
so what you have to do is basically you go 43 Q value 0, 0, then you switch to the next page and you enter roughly about 0.55 if I'm wrong. If I'm not wrong, 51.
We will have a plug and play of that just after she finishes, so you can explain it real time.
So actually, one of the important things about when we are looking at treating SA through Q is pupil size.
Yes.
Pupil size is a
Yes.
very important factor, and we Indians having small pupil size, I don't know whether it's a boon or a curse, but I think the future definitely would be a customized Q depending on your pupil size.
No, I don't think that you need to customize the Q depending on the pupil size. I disagree on that. I have a patent, by the way, on that. It's not published yet because it's in review. The important thing is, if you want to do presbyopia, you want to have a driving force of the pupil, right? The driving force is the pupil. So you have the nervus acromotorius, which does the conversion, does meiosis, and does accommodation. So accommodation's gone, conversion stays, meiosis becomes bigger with age. So what you want to have is that the spherical aberration fits within the optical zone that you want to create, and this optical zone fits to the pupil. The second thing that you need to know is, if he is a normal light condition, what pupil size does he have? Because this is very important to reach the refractive power that you want. Because if you change if you have different pupil sizes, you will have also different refractive result per slot. So in other words, I think if you want to customize, this is what you're asking, if you want to customize your Q value treatment, okay, I don't say the bad word, then you need to really look at the pupil dynamics and adjust it to optical zone, the slope of the Q. The asphericity has to stay 0.4, minus 0.4. This is agreed upon that you need roughly minus 0.4 micron. But the slope at the periphery, if it's for a 2 to 5 millimeter, I want to have a very flat slope. But if you have one that goes from 4 to 2, you want to have a steeper one.
Yeah, yeah.
Does it make sense?
I mean, that's completely true. But so, like you're saying, eventually the pupil is one of a key factor in how effective the Q works. Because in Caucasian eyes and Indian eyes, there's a lot of difference in what is photopic and mesopic. I mean, what the difference is, you know, the result of one particular value treatment in their eyes may be not the same results in our eyes. So there could be a little bit of difference. So I think.
I mean, I liked what
Let's
you presented. It was very, very good, because it's exactly the point.
Exactly.
If you have a pupil dynamic that is from 1.2 millimeter to 2 millimeter, if you do custom Q or adduction of spherical aberration for him for presbyopia, you're gonna lose.
Yeah.
There's no
Makes
volume.
sense.
So basically, what is coming in the future from, I mean, to make it very simple, even though this only Shruti has understood the whole thing, what is coming, Abhijit also, what is going to come is, I don't know how correct I am, but your presbyopia of Alcon is based on this graph, in a very simple, to make it very simple. That means all this calculation is already based, so you change it, this is what I saw, and you get it. So now Dr. Dami will actually have to use this graph in his mind to change and get what he wants. Can we use the plug and play for Dr. Dami, please?
So one question for you actually.
Dr. Dami, please on stage, you and Shruti.
So in the paper, Damien has also given comparison of the expected versus the obtained change in Q. So the question is, obtained change in Q on topography post-op is always going to be problematic.
Exactly.
How will surgeons evaluate that what they planned is actually what they got? Because this regression shows that it is not predictable.
It is not predictable because you can't measure. There's no way to post-op measure Q value.
So we should not look at the post-op Qs and
I
just
think
hope that
the only way to judge how much spherical aberration you got pre to post-op is to make a pre-op wavefront and a post-op wavefront and see if you induced the change, the refractive change you wanted.
Yeah.
The problem with topographies and measuring Q value is that you don't know where your treatment is preoperatively to post-operatively, because you don't know where your fixed points are. Wavelight did a big study in 2009 where we tried to reprocess what we did, and the only way was to take pentagram scans and start from the periphery in, but we knew internally how much volume we took away, and we tried to find it. And then we could find the change in asphericity. This is very complicated. Yeah. Maybe UST can do that. Great work, by the way. I don't know why nobody got to idea to polarize light. I mean, you are a genius.
We'll start off with one case because Dr. Dami has to take his flight. So let's say this is a 44-year-old person who wants reading glasses. This is a hyperope, right? Okay, just go. Which is this? This is a myope. You want a hyperope or myope to start with? Hyperope? Let's start with the hyperope. Because there's very few people in the country who actually used it very well. And last year we missed his inputs. So this is, keep moving. This is 1 plus 1 minus 1.5. Do you also take into consideration how much cylinder you have, or any cylinder is okay for you? You can use the mic, please.
Actually, we have been following a different way. We just note the pre-Q and then expect what we have to change it to. Any expected post-op Q. We found that the expected post-op Q to the range of minus 0.6 is very suitable to the patient what we want. Then amount of tissue ablated with a nomogram with this, because excess of tissue is being ablated. Adjust your sphere. But it's totally different than what I have just learned from yesterday.
So, for example, this is your patient, it's got a plus 1 minus 1.5, your Q is 0.032. Now what do we do? What is the next thing you do?
We have to plan what should be the post Q.
Okay.
We take it to be Q1, Q2 to be 0.06.
Can you change to 0.06? This is arbitrary. Whatever it is, you go to 0.06 or, okay.
0.6.
06.
0.6.
0.60.
0.6.
0.6.
Both.
Negative.
Minus.
Minus, both are minus. Okay.
Now, what is not here is the delta, difference between the
Difference
pre
in
and the post Q. So what we were using was a totally different nomogram, which had a different concept.
But now, based on this, what do you do next?
Find the delta Q.
How do you find that?
Difference between the pre and the post Q,
That was 0.3 now.
0.3.
Yeah.
Now, for 0.2, then you have a nomogram that you are making a Q change of this much of delta Q, you get an answer. There's a good mathematical calculation, and you get the amount of tissue being ablated by that.
So what
That's
you,
all.
yeah, okay, move forward.
I don't have the nomogram here.
Okay, no problem. Roughly you can say you move forward. And now what do we do? So you have a Q which is 0.59,
Okay.
which is your target Q.
Target Q.
You have a 6 millimeter zone and or 6.5 doesn't matter. And you have a ablation pattern like this. Do you do any more, you give any correction on that? It's a 45-year-old, she accepts 1.25?
I have not added the nomogram for the delta Q,
Okay.
which is a little painful calculation till you have a nomogram and a calculator. And that gives.
Yeah. Sister Moses, would you differ?
Can we maybe make us, can you give me 2 minutes to explain a little bit the Q value?
Yeah, come please. come
directly?
in. Yeah.
I think this is much easier to understand what we do. I
You
think
can
if-
actually sit and explain on the machine itself.
Yeah, would love to. So
Okay.
I would like first a little bit to go through the Q value, because I think we need to understand how many functions this Q value software has and what it can do. Okay. First thing, before going into, no, I don't want to have this. Planning, AX500, very good. Before we go into the treatment and change asphericity, let's understand what Custom Q software does. Custom Q software does bring sphere and cylinder together and makes one treatment. And this, as we discussed yesterday, it is a better treatment already for every patient and should be preferred to wavefront optimized. Okay, this would be now, we have here already the data. So it would be a very simple treatment to do Custom Q here, but just clicking on and on, don't change the Q value. This would be a good topography, would be already a better profile than any wavefront optimized. Now,
Just go back,
Let's-
Sister Moses, just go back. Just go back. This is important for people who don't know. If you want to see how your other planning all you have to do is the additional planning. Then can you click that? then it goes to all this, and then you can compare your ablation profile.
So I did now create one Q value treatment with the true measured Q value. I didn't change it. You see here it was 0.32, 0.32. I pressed again forward. This is one option how you can treat Q value treatments. Or you can do this with a 0,0 value. If you don't have a topolyzer or analyzer and you don't have a Q value, the easiest way is to key in here 0,0 and aim also for 0. Yeah? Which the software does automatically. This is going to be exactly like a wavefront optimized profile. The only difference is that you will have this now sphere and cylinder combined together, plus you can change your optical zones here in any way you want, from 6.5 to 6.7. You can change your transition zone if it's still possible. You can key in here a target that is, for example, minus 0.13, so it becomes plus 1.13. So you see it's a little bit more customizable and it's better. Now, let's compare this with the custom Q with the measured. So the ablation depth here is the custom Q with the target of 0,0. It's 27. And this is the one with the true Q value, which was minus 0.3. So you see there's a difference of 3 microns. Now what we can do is additional planning. I want you just to understand the use. The use is, if you want to have it with wavefront optimized with the same steps, don't take extra measurement, use 0,0. If you have the real Q value, keep it there as it is and continue. You will still have a better profile than with wavefront optimized. So this is the next step.
But to make it very simple, just 1 minute, Simosus, to make it simple, what he's trying to say is, if you are doing wavefront optimize, instead of wavefront optimize, you can do a custom Q, just like what he said.
Exactly.
So look, with the same results, it's not a topo-guided treatment, but it will probably be better than your wavefront optimize, but it's not going to be as good as your Contura maybe.
Exactly.
So when you are doing your wavefront optimize, instead of wavefront optimize, which is, I call it a plain vanilla treatment, you can add some, spice it up with something which is a custom Q. It's in between your wavefront optimize and the Contura.
How do we
Exactly.
do it for
If you compare,
non-dominant eye?
This is not for presbyopia.
No, if at all.
That you will come to it later, I guess.
we come to it. I want you to just understand
This
how
is
the
a plain,
software works.
this is a simple refractive correction for a patient who's come as 25-year-old with a -2 whatever.
Exactly. So I want you to understand the custom Q, because there's a lot of misconception, and was worried already that we start with the enhanced applications of custom Q. We don't go to the basics. And the basic is, if you want to have the same as wavefront optimized, but in a better profile, and look at this. This is the wavefront optimized, 24 microns, and this is the custom Q with 0,0. Ablation depth is equal. The only difference is now that you don't have first the sphere and then the cylinder, you will have it together, and the correction matrix is going to be applied accordingly. Now, let me give you a little bit more insights now into what is custom Q doing and how can you use it if you want to enhance stuff. And we discussed this yesterday, Dr. Dami, and I do this now in a different way. I do a custom Q, but instead of having here refraction, I put here 0, okay? We could use a different patient, but I want you to see the profiles to understand. So, and let's do here also 0. I would not consider the pre-op Q value of the patient at all if I want to make a change, because what the pre-op is not anymore of a concern. I want to create a certain spherical aberration or something, okay? Now, if we continue now, we have a nice gray ablation, no ablation, right? Very good. It is logical. I don't change, I don't have refraction, so everything should be 0. Now, what I want to have is, for example, an induction of a Q value, and I want to know actually what is this worth. So, for example, I went now from 0 to -56. Okay, let's look to the Zernike polynomials. So I do now an induction of plus 0.49 microns of spherical aberration. Now, if I want to achieve exactly 0.4, I know, this is too much, okay? So this is the reason I took 56, just to show you what we could do. Let's do a 51, okay? Zernike's, 0.45, still a little bit too much. I don't remember what it was. I think it was 46. Let me see. You know. So C12 is 0.41. Okay? This is what I want to induce, right? So I don't care what my pre-op Q values are. I don't care of this. I want to have a profile that does asphericity or induction of 0.46. Very good. Now, look at this.
I have a question.
Yes.
If we change the spherical error, this will change, right?
The-
If it does not depend on the...
Wait a minute. You are exactly the right way. Now, let me explain you what is happening. By inducing now the C12 of 0.41 microns, I have to compensate for 1.4 microns of sphere. And this is what Gatinel describes as Zernike polynomial errors. So because of the C12 of 0.4, I need to back calculate with some formulas 1.1 into the sphere to stay orthogonal. And this is the mathematical problem. Okay, how do we do this? We don't care about mathematics, we are practical. Too much mathematics is no good. Okay, it makes life miserable. So let's do minus 1.1, for example. Okay, let's see. So C4 is now minus 0.16. So I overdid it, most probably. And I show you how practical this can be used. So Zernike, okay, now we are 0. You see that? 0. Okay? So this is going to be, for the center now, neutral. Okay, what does this minus 0.5 tell me over there? It tells me that, for example, if you did a monovision of minus 0.75, you're gonna add minus 1 on top as a multifocality. And this is exactly what Gatinel describes. He says, with the amount of minus 0.4, you are creating a multifocality that is still acceptable for the patient without losing too much of far vision and without having, if you want too much side effects.
Glare.
And therefore, minus 1 with the, whatever you add to the patient, for example, 0.75, minus 1, minus 125, you're going to achieve the defocus or depth of focus that you want. So for me, important is to understand these two figures. This figure of compensation tells you also what a possible refractive change is pupilly driven. And what you can see here is, with the Zernike clicking here, you can see the amount of Q value that you're going to induce. So you see it's 0.38 now, and you see now how these Zernike polynomials are depending to each other. No? It went from 0.41 down to 0.38. Actually, I need to add a little bit again and do compensate again until I have the minus 0.4.
But what I want to tell all the delegates here is, I mean, for a mathematician, it looks very easy to play around with this. As a clinician, we are always worried about what would happen to the patient if we go wrong. So what I can tell you as a preview, I was seeing this software. I think the software has one box here where you have to change the Q and where you change it. So it will make very life simple whatever Dr. Dami and Dr. Sisimosos have been trying to tell us using their, using all their knowledge of mathematical driven thing in this. It will make it very easy that all you have to do is you have a particular nomogram, like how you have your Wellington nomogram. That's what I assume, that you feed in this, this is what you're going to get. You feed in this is what you're going to get. So that we don't really need to go into understanding if you don't want to. But like all refractive surgeons, the joy of refractive surgery is not in operating. The joy of Contura is not operating a Contura. Joy of Contura is trying to find what is missing and how to plug it. The whole idea of doing Contura is, it brings joy to your practice because you make things lively. Otherwise, if you're doing a wavefront optimize, it just gets too boring after some times because anybody can do the surgery. The joy of doing custom Q is because you can start thinking. And we don't think as refractive surgeons after some time, because here every case we can start thinking. So one of the take-home points from both the custom Q and the Contura is, if you start thinking, even though it may look a little complicated in the beginning, it brings a lot of joy to your practice, personally to all of us. I agree, Dr. Nitin?
Yes, sir. So I think we've been doing something very similar, but in a different way. And I would like you to, could you save this, please, as a treatment? Could you save this, and we could give it another try, if time permits, sir.
Let me see if I fine-tuned enough. So I fine-tuned now enough. My C12 is roughly 0.4. My compensation is -1. For me, just before I do this, please, I really repeat this so we don't forget. Custom Q is not there to change the Q value primarily. Custom Q was there to replace wavefront optimized into better. And how do you do that? If you don't have the measured Q, use 0, 0 and pre-op and 0 post-op, and go ahead, you have a better profile than wavefront optimized and more customizable. The second step to get even better profile is to use the real Q value that you measured with the topolyzer vario. If you have a vario, the easiest thing is do 2-3 measurements, shoot it off to the laser, you have the K readings, you have the name, you have everything there and registration, and then go ahead and don't change the Q value. This is the primary use, okay? This is the so-called, for me, advanced use, okay? This is the joy, okay? This before was the bread and butter, we say in German, and this is maybe the cherry on the whatever, in the gulfi or the what. No?
Can you just quickly run through Ritin so that we move to the next session? Because people have flights to catch.
Sir, I just wanted you to do another planning for this patient. If you can go into treatment planning, please.
Yes.
And custom Q, please. And we keep everything as it is, move forward.
But I should take the refraction, right?
No. So we'll keep 0, 0 refraction.
Okay.
I'll just want to compare it with what you've done.
Okay.
So here our measured Q is 0.32. And you made a change of 0.51. So that's our target Q is -0.83. You'll have to type it in.
It's not necessarily going to work.
I know, but I just want to show you what we've been doing and how we've been getting, and I think the result the ablation profile should be very similar. So what we started out in the center was 0, and let's just move the target refraction to +1, start lowering it, so that we reduce.
Okay.
You don't even have to do Zernicke. Yeah, we keep going down. Yeah, so right about there, just check the Zernicke now. And your C4 is 0.2. I would go still lower. Still lower.
Still lower?
Yeah.
From here to -0.15.
Yeah, yep. And
Zernicke?
yep. So we keep on changing this till we get to a no. So I think we've gone too far. We have to.
You went too far because now you induce hyperopia.
Now I'm increasing hyperopia.
Yeah. So the important thing is that this C4 becomes 0. If you don't get it to 0, you go on to induce something.
Some refractive change. So that's not what I want. I want to bring this to 0. So I think a refraction of -0.8 or -1 or so would be correct.
I think it should be very similar to
yes,
what
that's exactly the point that I wanted to make. So if you can just check on the Zernicke here.
Excuse me. Yeah. I was too fast. So Zernicke, it's now CO.
Very close. So if you can save this, and can you compare the two, that what you did and what we've done here? And this is how we've been doing custom Q for presbyopic. I have very low experience, still single digits, only maybe 7 eyes. And I've been trying to do a delta 0.6, yeah?
Pretty similar.
Yeah.
But this works, be careful, this works not always necessarily so linear, because it's a square function, so it depends if you get, for example, the danger there is if you have a Q value of minus 0.5 to start with, you can't do a Q value change of 0.6 anymore, okay?
I think you're very clever, sir, that you're working with hyperopia first, because our measured Q values after surgery would seem nicer. And once we're doing, so most of my cases that I've done are with myopia, and the patients do very well. We do get some depth of focus, but the measured Q value is not presentable. I can't say it on stage.
You can't measure it. You can't measure it. The reason why it's clever to start with hyperops is twofold. Pre-op, they don't have a good focus in the fine veneer, so you are not going to make their life so much more difficult. And the second thing is, if you do hyperopic ablation, you help actually the Q value to be achieved because you do a peripheral ablation. You know that pre-op to post-op hyperops, you have a more negative Q value, whether with the myops, you have more positive.
Question. Basically, you are inducing spherical aberration in the cornea to increase the depth of focus, right? So, along with your presbyopic result and the final Q, have you had any quality of vision problems in these patients? I would expect that the spherical aberration would also have that negative impact, right?
So, ma'am, it's very difficult to answer that question, but I like to take my surrogate as distance corrected visual acuity. So, I'm doing a wavefront optimized treatment practically for emetropia in the dominant eye, and I'm doing a monovision of maybe 0.5 to 0.75 depending on age, minus 0.5, 0.75 target correction, with a Q value adjustment of delta 0.6, minus delta 0.6. What I've noticed post-operatively is, if I refract these patients and give them the correction of the target refractive error, so I put a minus 0.75 lens in front of their eye, they tend to see very well 6.6. When we compare it to the other eye, they say it's fairly similar, it's not the same. But what also happens is that if you remove this 0.5 or you add a plus 0.5 to their eye, they still tend to see 6.9 while the other eye doesn't. So we do get a depth of focus which is increased, which you can actually measure on distance corrected visual acuity, and you can fog it around and see that it's not getting any worse. So that's because of the range that you're getting. Yeah, quantitatively, correct.
So we will break.
Not necessarily, not necessarily. The thing is, the idea is behind of adding spherical aberration. I mean, if you look to the Presby Max, micromonovision, whatever the others say, the basic idea is always the same. Spherical aberration to increase depth of focus. This is one way to look at it. Another way to look at it, and this is a very nice way as Dr. Gattinelli described this, if you have a patient that has a minus 1.75 of anisometropia, he will have a best corrected that is maybe 6/12, yeah? But with a spherical aberration, he has only minus 0.75 and the effects of minus 0.75, if you do it clever. He will be 6/9, as you say. So the idea is to make the anisometropia more chewable.